Alright, today's lesson will be on prime factorization. So to get started, let's talk about what prime numbers are. Well, a prime number is a number whose only factors are 1 and itself. So for instance, 3 is prime since 3 and 1 are its only factors. So we're going to have to use this idea of prime numbers to do prime factorization. So when we do prime factorization, we're going to use something called a factor tree. And basically what that does is we break numbers down into branches, which are factors or multiples. And we're going to keep on breaking down into branches until we get down to prime numbers. So here's an example. I'm going to start off with the number 36. And I'm going to do this two different ways to show you that doesn't matter how you start, you'll always get the same prime factorization. So 36 can be broken down into 9 times 4. But 4 and 9 both are not prime, so I need to break those down. So if I break down 4, I get 2 times 2. And since 2 is prime, I'm done with 4. And then to break down 9, I can have 3 times 3. So since all my bottom branches are prime, I have my prime factorization, which is 2 times 2 times 3 times 3. Again, I could do this a second way. Rather than having 4 and 9 as my first pair of factors, I can choose two different ones. Let's choose 6 and 6. So again, 6 isn't prime, so I need to break that down into branches. So 6 is 3 times 2. So again, 2 times 3 on the other 6. Now since those are all prime, my prime factorization is the same as before, 2 times 2 times 3 times 3. So no matter how you start, you get the same prime factorization. Alright, let's take a look at another example that's a little bit more difficult. So I have 125. I'm not sure of all the factor pairs of 125, but since it ends in 5, I know that 5 is a factor. So to find the other pair, I need to use long division. So 5 doesn't go into 1 because it's too big, but it goes into 12 twice. 5 times 2 gives me 10, so I subtract. 12 minus 10 gives me 2. Then I bring down the 5, so I have 25. 5 goes into 25 5 times. And 5 times 5 is 25. I subtract and get 0, so my other factor pair is 25. Because 5 times 25 gives me 125. But since 25 isn't prime, I need to factor that, and that is 5 times 5. Now I have all prime numbers, so my prime factorization is 5 times 5 times 5. Alright, one last example. I'm going to go through that process of using long division again. So I have 312. It's an even number. It ends in 0, 2, 4, 6, or 8. So I know 2 is a factor of that number. But I don't know the factor pair. So I'm going to have to use long division. So I have 312 divided by 2. 2 goes into 3 once. Do some subtraction, I get 1. Bring down the 1, I get 11. 2 goes into 11 5 times. 5 times 2 is 10. So I have 11 minus 10 gives me 1. Then I bring down the 2 and I have 12. And 2 goes into 12 6 times. So my factor pair is 156. Now 2 is prime but 156 is not. So again, since 156 ends in 6, I know that 2 is a factor because it ends in 0, 4, 6, 2, or 8. So again, I need to use long division to find the factor pair. 2 can't go into 1 because it's too big, but 2 goes into 15 7 times. And 7 times 2 is 14. Give me a remainder of 1, bring down the 6. 2 goes into 16 8 times, giving me a remainder of 0. So my factor pair is 78. Again, 78 ends in 0, 2, 4, 6, or 8, so I know that 2 is a factor. But I don't know the factor pair again, so I use long division. 2 goes into 78. 2 goes into 7 3 times, gives me 6, remainder of 1, bring down the 8. 2 goes into 18 9 times, gives me 18, subtract, get a remainder of 0. So 39 is my factor pair. So I have 78 breaks into 2 and 39. And then 39, since 3 and 9 are both divisible by 3, I know that 3 is a factor of 39. And if I was to use long division again, I would see that 3 goes into 39 13 times. So my factors are 3 and 13. Now I can see the bottom of my branches are all prime, so I have my prime factorization of 312, which is 2 times 2 times 2 times 3 times 13. And I'm done.